Hi everyone. This is a demo of a project called NativeJDB, which is a debugger for natively compiled Quarkus or any Java-based applications. So today we have a GDB, which is a C++ debugger to debug native executables, which is unfamiliar to most Java developers who are used to the IDE debugging experience. And additionally, it is pretty difficult even if you run it with Emacs. Today, there exists no integration of GDB with any Java IDEs. So our goal is to bridge this gap between native and Java debugging such that one can debug a native executable right from an IDE like IntelliJ. So this native JDB runs as a standalone application and wraps the GDB process, which itself wraps the native executable to be debugged. It also acts as a server that listens for the JDWP commands, which is a protocol used by the IDE to speak to a JVM. And then the native JDB translates those JDWP command packets to GDB commands and then translates back the GDB outputs to JDWP reply packets. So the IDE knows what to do. Today, NativeJDB gets all the information about the debugging process from both the suspended JVM and the running GDB process. So this is the code repository associated with this project. It is on a GitHub NativeJDB organization, and you can find more information about our motivation and our architecture here. So let's start the demo and switch to my IntelliJ view. So what I did to prep for this demo is I already ran the commands needed to build the native executable and also build our native JDB code into Docker images. They're basically just makefile targets. So all we need to do here is run the containers. Now, why are we running in Docker? That's because native image generation today only produces debug information for Linux environments, not for macOS. And this also provides appropriate source mapping back to the original Java source code. And our IntelliJ debugger can be attached to this native JDB Docker using a remote debug configuration. Let me quickly show you what it looks like right here. And usually you have some kind of Java process. You start with the JDWP agent, which becomes a server that listens for JDWP packets, and you can attach to it. In our case, native JDB itself acts as a JDWP server, and we're going to attach to it to start our JDWP packet exchange. So we currently have an architecture in place to send back and forth communication, both synchronous and asynchronous messages between our IDE debugger and the GDB that is running inside a Docker container. So let me go ahead and start up the container running our server. The image is already ready, and I'm going to start it by just running make run. So now our JDWP server is listening and is waiting for our IntelliJ debugger to attach to it. And before I do that, let me set a few breakpoints in my Java source code right in this IDE. Let's put one here and another one here and one last one in the main function. Okay, I'm going to start the debugger, debug hello nested. Okay, so at the bottom right, this terminal here shows the corresponding GDB outputs. As you can see here, you can see that the GDB has started with the native executable, and it has already inserted the breakpoints in the native executable itself, matching what we have inserted here in the IDE. The line numbers match, line number 9, 21, and 36. So we're in good agreement between the IDE and the GDB process. So we're in suspended state and now ready for debugging. And there you go. We've hit the very first breakpoint. The GDB output here shows that it has paused because of a breakpoint hit. And GDB simultaneously has informed the IDE here because now we're also paused in the IDE. The debugger window here on the left shows the stack frame information, which is information that actually comes from the GDB process. We don't have values for local variables and fields in the variables pane here yet because it's a work in progress. So what I'm going to do next is I'm going to press the step over button to show you the step feature. And as you can see here, the GDB process has also taken a step and returned the new stack information, updated the line and where it is. So pressing resume here now jumps from one breakpoint to the next while also updating the frame information. Let me do that one more time so we can jump to the next breakpoint. And one last time. Once we reach the end of this program, you'll see that the GDB is going to first exit right here, and it lets the IDE know via JDWP, and then the debugger also gracefully makes its way out. So as you can see via this demo that by using the IDE debugger, as I normally would with any Java application, I'm also able to control the GDB process and I'm sort of directly debugging the corresponding native executable as well. So from a user experience point of view, the user is able to develop a Quarkus application in Java IDE, and when it's time for debugging, they can actually run our target commands to build the native executable in Docker, then start up the NativeJDB as a debugging server attached to it from the IDE like I showed you, and then just do normal debugging functions right on the Java code that is open in the same IDE editor. Great, so there are more exciting features to come soon in this project. Thank you.